module, you will learn briefly about the laws of motion and inertia. In your study of kinematics, you have learned how to deal with the displacement, velocity, and acceleration of a body in motion without considering the forces responsible for the motion. However, in kinetics, you are going to study the variables of a body in motion along with the forces that are responsible for the motion. Let us take the example of the start of a football match. The football would not move until a player kicks it. If you want to load a barrel onto a truck, will it go up just by itself because you want it to? No. You have to either lift it or roll it onto the truck. In each of these cases, the body was at rest until an external force was applied to move it. Similarly, when a barrel is being unloaded from a truck using an inclined plane, it tends to roll down fast unless its motion is restricted by some opposing force. In this case, the barrel has a tendency to move faster, but is being restricted by a force due to an external agency. In all these examples, the external agency applying the force was in contact with the object in motion. Hence, these forces are known as contact forces. When you drop a ball out of a window, it falls down. How did the ball go down when you did not apply any force on it? The agency applying the force is the earth, and the force is called gravitational force. This gravitational force is invisible and is a non-contact force. If you take a magnet near an iron nail placed on a table, the nail moves. Here again, there is an invisible force acting, which is magnetic force. Magnetic force is also a non-contact force. In all these examples, we saw that an external agency applies a force, either contact or non-contact, to accelerate a body, which is at rest, or to retard the motion of a body, which is in motion. Thus, we can say that a force applied by an external agency either accelerates or retards a body. Now consider a body moving with a constant velocity. Is there a need for an external agency to apply a force to maintain this motion? Yes. External force is required if the body is in our world, where frictional force acts on all the objects. However, in the absence of friction, like in space, no external force is required to maintain uniform motion in a straight line. To answer this question without any ambiguity, we first have to go into the history of kinetics and see what mistakes were committed before Newton's laws of motion were postulated. Aristotle put forward his view. An external force is required to keep a body in motion. This seems to be right when you apply it to all the day-to-day activities taking place around us. For example, to pull a toy, a boy applies a pulling force on the string attached to the toy. As soon as he drops the string, the toy stops. It seems as if what Aristotle said holds well in this example. However, If you carefully analyze the external forces acting on the toy, you will find that the pull exerted by the boy is actually equal to and opposite to the frictional force between the toy and the ground, which is again an external force. And hence, the net force acting on the toy is 0. We can thus conclude that the force applied by the boy is not in any way responsible for the motion of the toy car. In fact, the applied force just helps in overcoming the friction experienced by the toy. This is an example from our existing world. Now, let us go into a virtual world where there is no friction of any kind. Then the boy need not apply any force to keep the toy moving with uniform velocity. This is exactly what Galileo said. Galileo proved that no external force is required to move a body with uniform velocity in the absence of friction. Galileo conducted 2 simple experiments before postulating the law of inertia. The first experiment was with one inclined plane. A roller rolling down an inclined plane on its own accelerates. A roller rolling up an inclined plane on its own retards. A roller rolling on a horizontal plane neither accelerates nor retards, which means that the roller should move with constant velocity when there is no friction between the roller and the horizontal plane. The second experiment was with 2 inclined planes. When the slope of the 2 inclined planes is the same, a roller released from rest on one plane rolls down that plane and climbs up the other plane to the same height from which it was released, or a little less. When the slope of the second plane is reduced, the roller climbs up to the same height, but this time it travels a longer distance. When the slope of the second plane is made 0, that is, it becomes horizontal, the roller moves infinite distance. This can happen only in a situation where there is no friction. Actually, the roller comes to rest after moving some distance as frictional force acts opposing the motion. From these experiments, Galileo concluded that in either case, the state of rest and the state of uniform linear motion with constant velocity, the net force exerted on a body by the external agencies is 0. Therefore, to maintain uniform velocity, the external force required is only equal to but opposite to the frictional force, such that the net external force is 0. Let us put the same statement in other words. When the net external force applied on a body is 0, a body that is at rest remains at rest, and a body that is moving with uniform velocity in a straight line will continue to do so. The tendency of a body at rest to remain at rest, or of a body moving with uniform velocity in a straight line to stay in motion with the same uniform velocity, when the net external force is 0, is called inertia. In simple terms, inertia means resistance to change or resistance to acceleration. You have now reached the end of this module. In this module, you learned that kinetics is the study of the displacement, velocity, and acceleration of a body in motion along with the forces responsible for the motion. A force applied by an external agency either accelerates or retards a body. The tendency of a body at rest to remain at rest, or of a body moving with uniform velocity in a straight line to stay in motion with the same uniform velocity when the net external force is zero, is called inertia. Inertia also means resistance to change or resistance to acceleration.